Neutron stars are incredibly dense objects that aren't quite as mysterious as black holes. Deep within their cores, we may discover the most perilous substance known to science, something called strange matter. Strange matter is an astonishing and extreme material that can defy the natural laws of the universe and has the potential to either corrupt and obliterate everything it touches or enlighten us about the universe's origins. Maybe it could do both. Neutron stars. To truly grasp the exceptional nature of strange matter, we need to start with some basic information. What exactly is a neutron star, and how does strange matter disrupt the fundamental laws of the universe? In this video, we'll simplify some concepts, but if you want more in-depth explanations, we'll guide you to additional resources. A neutron star forms after an enormously massive star goes supernova. During this cataclysmic event, the star's core collapses due to its own powerful gravity. This collapse exerts such intense pressure that it forces atomic nuclei and particles to merge violently. Electrons are squeezed into protons, causing them to merge and transform into neutrons. The empty spaces within atoms are suddenly filled with particles that intensely repel each other, but have no choice in the matter. They push back fiercely against gravity, resisting the collapse. If gravity prevails, a black hole forms. If they succeed, a neutron star emerges. This turns neutron stars into colossal atomic nuclei, equivalent in size to a city, but containing the mass of our sun. And this is where things start to get strange. The conditions in the core of a neutron star are so extreme that the rules of nuclear physics become altered. This alteration could lead to the formation of a peculiar and exceedingly hazardous substance. But we'll explore this further in the following sections. Quark stars. Before we delve into how quark stars work, let's understand the rules governing them. Protons and neutrons, the tiny particles found in the cores of atoms, are composed of even tinier particles called quarks. Quarks are quite social. They prefer not to be alone. We say they're confined. You can try to separate them, but the more you pull them apart, the harder they try to stick together. In fact, when you apply a lot of energy, quarks use it to create new quarks. Quarks exist only in groups, serving as the building blocks for other particles, and we've never seen them on their own. While there are many types of quarks, only two seem to create stable matter: the up and down quarks present in protons and neutrons. All other quarks tend to disappear quickly, although things might be different inside neutron stars. The conditions within a neutron star's core are so extreme that they resemble the universe shortly after the Big Bang. Neutron star cores are like time capsules, offering us a glimpse into the universe's origins. So understanding how quarks behave within a neutron star is a way of deciphering the very essence of the universe itself. One idea is that inside the core of a neutron star, protons and neutrons break free from their usual groupings. All these particles, tightly packed side by side, dissolve and merge into a kind of quark soup. Countless particles come together to form one massive entity comprised entirely of quarks. Strange matter. Now let's get to the heart of the matter, quite literally. If the pressure inside a quark star reaches a certain point, it can turn even more peculiar. Within the cores of neutron stars, some of the quarks may transform into strange quarks. These strange quarks have some rather odd properties in the world of nuclear physics. They're heavier and, for lack of a better word, more robust. If these strange quarks come into play, they can create something known as strange matter. Strange matter might just be the perfect state of substance, incredibly dense, remarkably stable, and seemingly indestructible, more stable than any other material in the entire universe. It's so resilient that it could exist outside of neutron stars. However, there's a potential problem here. Strange matter might be infectious. When it encounters regular matter, it can impress it with its stability to the point where the regular matter begins to transform into strange matter as well. Protons and neutrons would dissolve into the quark bath, releasing energy and producing even more strange matter. The only way to get rid of it is to toss it into a black hole. But then again, why worry? This peculiar substance resides mostly inside neutron stars, except during the rare events when neutron stars collide with each other or with black holes. During these events, they release a tremendous amount of their contents, including tiny droplets of strange matter called strangelets. Strangelets are incredibly dense, comparable to the core of a neutron star. They can be quite small, perhaps even subatomic, but even the largest strangelets wouldn't be larger than a rocket. These strangelets drift through the galaxy for millions or even billions of years until they accidentally encounter a star or planet. If a strangelet were to strike Earth, it would swiftly begin converting our planet into strange matter. As it converts more, it grows larger, eventually transforming all the atoms that make up Earth. Our planet would become a hot mass of strange matter, roughly the size of an asteroid. If a strangelet happened to collide with the Sun, it would cause the Sun to collapse into a strange star, gradually consuming it like fire through a dry forest. This wouldn't significantly change the Sun's mass, but it would make the Sun significantly less bright. In turn, Earth would freeze to death, and like a stealthy virus, we'd have no way to predict the arrival of a strangelet. What's even more concerning, some theories suggest that strangelets might be more common than we think, possibly outnumbering all the stars in our galaxy. They could have formed shortly after the Big Bang, when the universe was hot and dense, resembling the conditions in the core of a neutron star everywhere. These strangelets might be clustering around the gravitational pull of galaxies as the universe continues to expand and evolve. It's even possible that strangelets, because of their abundance and mass, could be the elusive dark matter that we suspect holds galaxies together. But then again, maybe not. While the speculation about strangelets wreaking havoc on our universe remains just that, speculation, the Earth, Sun, and planets have not succumbed to a strangelet wildfire in the past billion years. So the odds are in our favor, and such an event is unlikely to happen anytime soon. Understanding these enigmatic objects today could be the key to unraveling the mysteries of our universe's birth and how it evolved into the state we see today. Just as early scientists who dabbled with magnets and wires could never have predicted the incredible technological advances of the past century, the scientists exploring neutron stars and strange matter today may be paving the way for a future beyond our wildest dreams, or maybe not. Only time will tell.